I'm still in Milan, Indiana, calling in from the little internet cafe here. I only have about an hour because that's all the internet time I get a day. I've been bartering with the owner, Roy Donk, for internet time. He needs bottles to bottle his gazpacho that he makes in the internet cafe. So I go to the bottle dump, get him some bottles, and get an hour's worth of internet time in exchange. So
Well, I'm glad you got on. I'm glad your barter barter and trade system for the internet today is well, bartering is alive and well in Indiana, it sounds.
when you're in my situation at this point, you got to make ends meet, but we can talk about that another time.
Y'all submitted, which was a feat in itself, it seems. I read it over last night with everyone, and we were all very happy with it. Wondering if you want to take us through some of it, and then we could all have like Q&A with you here.
Yeah, I think that would be great. With every big data bowl, there's going to be a key component that I think a lot of teams will focus on or try to do. It's often relating some type of probability, right? Like last year, pressure probability was a very popular theme. This year, because pressure is not so much different from like tackling as a skill, tackle probability was also going to kind of be a key component. With that in mind, it's always good to think of that as like a starting point, but realize that, all right, we're going to need to layer on something more interesting than just kind of saying, well, what's the probability of a tackle here? And I think right away, one of the things that came to mind for me was tackling is fundamentally two separate skills. Whereas with pressure probability, you have a quarterback who's generally fairly stationary and busy trying to do something else so that if you just get to the quarterback, so that's where the whole like strain, distance to the quarterback and speed thing comes in. That's probably really powerful in and of itself with just those two features is different in that like the ball carrier is often moving at a pretty high speed as well. And we've all seen those plays where the defender gets in the pass, kind of waiting on them, and the ball carrier just bowls them over. So I think the first thing that do with tackling was break it out into two skill sets. Pursuing the ball carrier to create an opportunity for a tackle, and then once you get that opportunity for a tackle, are you able to execute it? Are you able to show proper technique? Are you able to come at the right angle? Are you able to come with enough speed and force to make sure that that tackle actually occurs? With that in mind, we looked at tackling holistically. Maybe wasn't the best strategy. I'll talk about that more a little later. But looking at tackling holistically, I do think it was right to break it out into two different skills. But maybe trying to look at both within one project was a bit too ambitious. But anyway, that was the general premise. And then with that, really thinking about analogous problems in different domains. The other thing that jumped in my head when the data came out in the first couple weeks is both missile tracking systems and predator-prey relationships. So obviously there's work done with missile tracking to find the most efficient route in intercepting a moving target. Similarly, in the natural world, because the margins of life and death are so thin, biological like processes, I don't know what a better word for it is, tend to be really hyper efficient. So like predators need to be hyper efficient when capturing their prey. And not only do they need to get to that prey, they need to execute effectively. So that's where like the idea for Predator came from was, all right, tackling is these two separate skills, and we think it mimics this predator-prey relationship, and boom, that's where kind of the inspiration came from, and that's where we started down the path of looking into how we can kind of model that.
I think I think there were two places where, uh, you know, as we were reading it last night, there were two places where I think we had maybe the most questions.
Yeah,
The first question that we had was like, uh, if you're modeling two aspects of tackling, right? The pursuit of it, and then ultimately the execution of it. There's a lot of entries so far where their assumption is the pursuit is the majority of the behavior, and that if you get within a certain area or distance from the ball carrier, you're just implicitly going to tackle. So, I guess, how do you rectify the idea of like, well, a lot of people are just like assuming or implying that pursuit and good pursuit is perhaps more important than the tackle execution in general.
in terms of weighting the two skill sets, I think it really depends on context. I mean, one of the interesting things in looking at the pass plays, how often, and this is kind of anecdotal, I didn't like systematically look at this, but how many pass plays do you take a look at where really the defender's already in a decent spot because they were in coverage, and you actually don't have much of a pursuit going on. I want to say maybe 30 to 40% of pass plays in the data set had less than 3 yards after catch. And you can catch the ball and kind of fall forward a couple yards. Like, it's not exactly like the tracking data is so precise that exactly where you fall is where the ball gets spotted. So a lot of those instances are instances where player needs to execute a tackle having made no pursuit. So that was another reason I think we wanted to try to be more holistic, kind of capture these two skills and have it affect as many of the plays in the data set as possible. Because if you're not pursuing, you can still end up in the spot where you need to execute a tackle. I also think it would be interesting, and I didn't really get around to it given the timing, but once you execute the tackle, do you limit the yards? How well do you limit the yards post-contact that the running back or wide receiver or tight end is able to gain? We've all seen instances where a player makes a tackle, but if they're not doing so with a ton of force, it's like an arm tackle, they can still give up a few extra yards. And are there players that at point of contact tend to come in with such force and speed that they drive the ball carrier back? So all of that is to say, I think execution may not be as important as pursuit, but I think it's still a really important part of tackling. And it was hard to wrap my head around it with 2D data because a lot of the technique that goes into tackling is kind of about getting leverage in kind of 3 dimensions, like getting low. I mean, this is way back, but like grade school tackling drills, it was all about who could get lower than the other person to execute that tackle effectively.
Yeah, there is like that missing component of leverage. When I was doing the the penalty targeting work that we were doing on stream, the lack of the Z axis really helps or really hurts your assumption, because a similar tackle can be, you know, the same tackle can be at the thighs or at the shoulders, and it's going to be two completely different techniques. So, but yeah, that's an interesting point of like technique wise, more data probably would help a lot, but it seemed that you were able to infer a lot from just the XY data that was provided in terms of tackle execution.
Yeah, I mean, I was fairly pleased with, and if I had 10,000 words to spill, I would have spent more time on this, but I was fairly pleased with the level of variability within the hierarchical model between NFL IDs. And one of the things I looked at, like there's a mountain of stuff that I looked at that didn't get included, but one of the things I looked at was taking players, grouping them by position, and like substituting players in the situation another player was within that same context, and looking at the difference in expected tackles. So like if you had two different cornerbacks and they had 50 tackle opportunities and 60 tackle opportunities, kind of switching the intercepts and seeing how different the results would be in terms of probabilities. And it wasn't crazy, because the data set honestly doesn't, when you break it down by player, doesn't have that many tackle opportunities. Like I would say maybe 200 to 300 players had 30 plus tackle opportunities, but I mean you would get deviations of like 5 to 6 successful tackles on some of the players, which for the sample size is fairly significant. I don't know necessarily, if the difference between missing 5 or 6 tackles in a 9-week period is exactly going to be, earth-shattering in terms of EPA or outcomes, but for the sample size, that seemed like a pretty decent effect size.
Okay. Another question was more about the feature engineering side of things. We one figure, this particular figure, started somewhat of a discussion at the end of the stream last night, but particularly in step 2, where if you're able to change direction in a particular frame, there's a penalty of 3% of speed. In the penalty for speed, people, there was a question about whether or not this was coming from just domain assumption, or if this was something that was like investigated and applied.
Yeah, unfortunately for that particular piece, it was more assumption than applied. What I wanted, and once again, this is kind of like there were a ton of rabbit holes that I went down, that ultimately I kind of had to simplify in order to kind of get to the end and the deadline. I was trying to look at basically the change in speed when certain degree turns were made. The problem is, from what I showed, a few, I don't know if it was like 4 or 5 weeks back when I was looking at speed curves, is like there's so much confounding and contextual information missing of like, why did this guy slow down significantly when they were making a turn versus not? Like, and so ultimately, I kind of had to land on some type of assumption where I wanted to make it such that like you didn't automatically just get to change directions immediately to follow your optimal path. You did have to do some type of turning mechanism, but after playing with a few different penalties, some penalties I'd play with, I think I immediately went to like a 10% penalty, and that was so harsh that like optimal paths didn't exist on like 70% of the plays. And so it was kind of a mixture of assumptions and kind of playing with the data. But unfortunately, I didn't have any strong background to like inform that or anything to really ground it in like observation or empirical evidence. The other thing I tried to do with speed penalties was actually utilize the curve and basically make the player move a certain amount back down the curve, and then they could start going back up the curve. But that turned out to be fairly complex. And once again, if I had more time, I might have worked on figuring that out, but it ended up being something where, all right, to make this more realistic, I want to penalize turning behavior so that you just don't automatically get to flip straight to the ball carrier, but I don't have a strong foundation for deriving this penalty.
Okay. One question about, I guess, the additive value of the app versus just what you've presented in the paper. I think the number one thing here, the interactivity of it is very neat, and I think it might even overshadow some of the other tabs that do explain optimal path and also just play by play each play and its subsequent metrics that you've created, that my team's created.
Yep.
Yes, right. I think we were all really impressed with the idea of the optimal curves or the optimal path, and this ghost dropping and then catching up to a player. In the case of being able to like move a defender and maybe utilize this in some way, was there any idea of like realistic adjustment versus just put a guy wherever? Because like here we're able to put like a defender just illegally in places, right? And then it will give you a number, but in the form of interactive recommendation, I know some people would say like, oh well, boundless and then let domain lead you to the right spot, in lieu of having optimal path curves be the recommendation. Like, this is sort of a boundless problem at this point. Do you feel like this was an additive thing, or do you feel like this like is detracting or distracting from the idea of optimal path?
I feel like it's a somewhat additive thing, but it is a bit of a distraction, and this is where I'll touch on probably one of the biggest flaws in my process and why I am truly an amateur at this versus someone who looks at this data often and has a strong idea of what they wanted to do going into this project. Our outcome here, I think, was trying to thread the needle on a few too many cool ideas that we had in the brainstorming process. Initially, I'd almost wanted to think of entering the coaching track with some type of interactive application that allowed a coach to quickly take a look at a play after it occurred and basically move that player around in a way where they could suggest, hey, as a safety, you got drawn to the slot receiver. You basically made it more likely that an explosive play would occur. If you had been in this position, here's what the expected yards would have been. Here's what your tackle probability would have been. Here's here's what your optimal path would have been. And so, ultimately, concept then didn't get 100% tied or integrated to the optimal path concept in a way where they both converged by the end of this product. So I think we got close to that point, but unfortunately, you're right. It may be oh, this is really cool, but it isn't 100% aligned with the report that we put together. So I think it's a nice way to show how you could take this work and then apply it to something that could be used post game in review. But I wish we'd gotten some of the optimal path stuff in there. To your point, there's maybe some recommendations, you could think of a density underneath a player of this is where we would suggest this player goes within the bounds of knowing the formation or knowing the particular play. That's the other thing that we don't really have context for here is we don't know what the defender necessarily was supposed to do. Were you playing zone? Were you playing man? So it kind of ends up being a choose your own adventure type situation without recommendations from the optimal paths or recommendations in any way like that.
Okay. I don't really have a ton else in terms of questions. If chat has questions, we could take chat questions, but was there any insight in terms of this project or the team or anything that you wanted to highlight that might go unnoticed?
I mean, once again, I think there's probably a lot of learnings that maybe next year I'll actually remember. That I think I repeated some of the errors in the first year of not having a crystal clear thesis on what I wanted to do, and then allowing that to create too much work that ultimately didn't make it into the project. Just because I think we identified, there's this component of tax, this wrinkle that people aren't going to think about. Last year with pressure, the wrinkle for me was pressure impacts completion. Even if you don't get a sack, even if really you don't get right next to the quarterback, it is going to change the quarterback's decision making in a way that has second, third order effects. But I wasn't confident enough in that idea, or I didn't have it nailed down enough that I was also let me do, pressure over projected for position. Let me make a few other metrics. Let me do a lot of other things in the hopes that 3 or 4 things together is more powerful than one. I think that the ideas that make me go, oh man, that's awesome, strain, are the ones that are so crystal clear and simple that you just look at them and you're duh, yes, that's straightforward, that's easy to explain, like that's at the heart of the issue. And so I think getting to that like really clear idea is probably the hardest part of all of this. Um, because if you don't get there, given the time constraints of the project and like the time constraints I have in my life, I've got like an hour here, an hour there at 10 or 11 p.m. in the evening to work on this. It's like if I don't get it crystal clear quickly, it's going to be a lot of chasing my tail. And that's the one thing that I think next year I'll be like, all right, let me evaluate this problem and think about if I can come up with like a crystal clear idea. Because if I'm going to end up just grasping at straws again, I think it'll just be kind of the same process of let's go down this rabbit hole, let's go down that rabbit hole. Like the amount of time I spent trying to figure out the speed curve from the standpoint of how quickly an athlete hits their 10 and 20 yard splits and then how much that deviates between athletes was too much time to spend on something like that. It's very easy to get caught in those details. And ultimately I found some decent data that suggested there's actually not that much variability between like your 10 and 20. It's in terms of percentage of time. But yeah. The other thing I was hoping to do that I'll comment on that kind of I think would be really interesting, and I don't know if it's like too far out there, too disconnected from reality, but we were talking about as a team taking optimal pursuit, mathematical standpoint, and instead of using classical pursuit curves, trying to use reinforcement learning to understand the paths defenders might take to ball carriers and set it up in a way where obviously yards would be the reward for the ball carrier, and then the defenders would be rewarded for increasing their tackle probability, and seeing if there's a difference in the strategy or behavior of defenders when they behave in a selfish way versus a cooperative way. I think it'd be really interesting to try to put a value on a guy on defense who attracts multiple blockers, leaving another defender to execute the tackle or have the opportunity to make a tackle. So one of the things we were thinking about was doing that and using the speed curves obviously to inform how quickly a player can move turn to turn within a reinforcement learning environment. But ultimately,
ultimately,
with that, like,
okay. Okay. People are asking if your internet time is running out.
I just talked to Roy. He's going to give me a few extra minutes. I got to go back to the bottle, a couple more bottles. But he said if I go back tonight, he'll let me have another 5 minutes. So I'm back. He turned my internet back on.
Okay. One thing that I've been reading early entry is for a few weeks now, and one thing that people ended up doing was creating creating models based off the events that are happening, as opposed to um, the events that we would have to infer from just watching football. But the events of, like, from the point of ball carrier has the ball to the point of first contact, and then the point of first contact to the actual tackle event happening. And so this sort of, like, illuminates the idea of pursuit and then execution. The pursuit being from the point of when the ball carrier becomes a ball carrier to the point of first contact, and then execution being the point of first contact, and then do you save yards gained by converting first contact into a successful tackle. Was there any thoughts in terms of using those sort of events as opposed to just training on all data and modeling the behavior or the motion of players? Like, do you think that would have helped at all, or do you think, like, that wouldn't have fit the framework of what you and the team were trying to do?
I think it would have helped. So to clarify that, kind of the frames of interest, for run plays, we started when the handoff occurred. Basically, that's your timer starting for pursuit. And then for pass plays, it was when the pass was caught. We did not use first contact. In hindsight, I kind of wish I had investigated that more. First contact to me as a label seemed somewhat vague. Like, what defines contact? I mean, particularly on run plays, given the close quarters at which a running back is trying to basically break through the offensive line and get to the second level, where the linebackers are and the secondary are, you get a lot of contact in those situations that isn't even close to a true tackle or tackle attempt. Now, that said, I don't know how often that happens in the data. I don't know. I mean, it probably would have been good to look at first contact and how speed of the ball carrier changes with that contact, to maybe identify contact that's somewhat meaningful. But in hindsight, I do wish I'd spent more time looking at that event in particular and getting a grasp on, should I really look at it from the point of first contact on? Should I include first contact in my tackle execution model? That was another thing I looked at, was just simply saying, what if I considered any player within... So if you look at the distribution of distance from ball carrier to tackler when the tackle event occurred, could I use that to roughly approximate some type of radius around the ball carrier and then say, anybody that's within this radius has created a tackle opportunity, therefore I should see whether they can execute on that opportunity. Ultimately, I didn't do that because it seemed like there are a lot of instances where, once again, the defender is very close to a ball carrier but not facing them, or really not able to even try to execute a tackle because of blocking, etc. But I do wish I'd looked at first contact and got a better feel for exactly what that meant. I think I shied away from it early on because it seemed kind of vague. But I think maybe if I had explored it a little bit more, it would have been really useful to use that as context with either the tackle execution model or kind of in the context of yards allowed or yards saved.
Okay. Well, I don't want you to lose internet for tomorrow, but any parting thoughts?
I don't know. I will have to think about that question and return to it because actually, one parting thought. Seriously consider whether you want to take on these type of projects with two small children, because one, I could handle it. Two, significantly decrease the amount of free time I had, particularly when they start getting each other sick, and then they just get in a sick cycle, and you end up with less free time than you thought. So, yeah, this is a message to all the youths. Get your side projects in, your side hustles in, while you can, because that time's gonna evaporate really quickly, and you're gonna be grinding out charts at 3 a.m. watching 18 different plays to find one that you want to put in your presentation.
Any updates from the team before you go?
So, I haven't been in touch with the team since we submitted. I'm gonna have to reach out to them. I know that like things have kind of gone south since we got kicked out of the apartment in Indianapolis. But I'll report back next week with the happenings of the team. But we've kind of been scattered to the wind ever since the landlord kicked us out of Indy.
Right. Okay, well, I'll let you go here. The chat is very proud that they were able to follow this through from beginning to end, and I'm very nervous still, but I'm very excited. This is quality stuff, and on the read through last night, yeah, I mean, I hadn't seen it all put together yet, and I had only known bits and pieces, and going through it, it was really good. It felt a lot longer than it actually was, which I think was good. It felt like I covered a lot of details that perhaps most submissions might be only covering a single model at times, and this one covered 7 of them. So kudos to the optimization of language here. But yeah, I think we're all excited. We're all rooting for y'all. Obviously, you have to root for yourself, but also this chat has to root for me because I am the owner. So we're all rooting for you.
I'm just happy to get back to my real passion, which is Aussie Rules football analytics. Season's starting in a couple months. I got to get back on the Aussie Rules grind.
All right, well, congrats on submitting. You did it. The team did it. And we're just waiting at this point.
Yep. All right, Roy's giving me the signal. He's telling me it's time. He's going to cut my internet off.
Okay. All right. Well, good luck, and yes, congrats.
All right. Thanks, Nick. Thanks, chat. Take it easy.
So yeah, there you go, y'all. There's some behind the scenes on Predator. Do you ever lose sleep at night knowing Jason Baseball is always holding a baseball bat behind you? No, Jason Baseball would never hurt me. Okay? That's the thing. Jason Baseball would never hurt me.
Jason Baseball would never hurt me.